Hello everyone, welcome back to Celestial Tutors. In this video, we are going to learn how to graph inverse trigonometric functions. And first, we are going to work on sine inverse function. But before working on graph of sine inverse function, we have to look over the graph of original sin x function. We are already familiar with this graph of sin x. The domain of this graph is negative infinity to infinity. This is defined for all real numbers. And the range of this graph is negative 1 to 1. Domain represent the x values and range represent the y values. And we know that for an inverse function, the x and y values get exchanged. Domain becomes the range and range becomes the domain of the inverse function. But we have to be careful. Any function can have inverse function only when it passes the horizontal line test. And if we draw a horizontal line across this graph, it intersects at more than one point. That means this graph is not passing the horizontal line test. That means this function cannot have an inverse function for the all real numbers. So to be able to get the inverse of sin x, we have to restrict its domain. And we observe that if we keep only this part of the graph from negative pi over 2 to pi over 2, it passes the horizontal line test. And if we delete all the graph before negative pi over 2 and after pi over 2 and keep only this part of the graph, then it passes the horizontal line test and then it can have the inverse function. And we know that for an inverse function, x and y values get exchanged. So the x values comes along the y-axis and the y values come along the x-axis. They get exchanged. Here we have restricted the domain from negative pi over 2 to pi over 2, which is the range for the inverse function. So range would be negative pi over 2 to pi over 2. The restricted domain here from negative pi over 2 to pi over 2 becomes the range of inverse function here, and the domain of inverse function is the range of original sine function. So the domain would be negative 1 to 1. We have taken the domain as the x value, so they are taken along the x-axis and the range values are taken along the y-axis. Now we are going to draw this graph. First we write the important points of this sin x graph. It's negative pi over 2, negative 1, then 0, 0, and this point is pi over 2, positive 1. All these were x values and these were the y values. Now they get exchanged. Y values become the x values and x values become the y values. So the point becomes negative 1, negative pi over 2, 0, 0 remains same, and the third point pi over 2 comma 1 becomes 1 pi over 2. Now we are going to plot those points here. Negative 1, negative pi over 2 is here, 0, 0 is here, and 1 pi over 2 is here. Now these points seems to be in a straight line, but they are not actually. When you draw the intermediate points as well, like pi over 3, the values at pi over 3 and pi over 4, you would get the shape like this. It's concave up from 0 to 1 and concave down from negative 1 to 0. So this is the graph of sine inverse x. Since this is an inverse graph, you can observe the part which was concave up on this graph, on the original graph, is concave down on the inverse graph. From negative pi over 2 to 0, it was concave up, but it is concave down from negative 1 to 0 here. And 0 onwards, it's concave up. Here it was concave down, but here it is concave up. So the part which was concave up here becomes the concave down here, and the concave down part becomes concave up here. Let's work on this problem to understand this concept better. First of all, we write the given function as y equals 2 sin x plus 1. Since we need to find the inverse of this function, so we switch over x and y. And then we isolate y step by step. First we subtract 1 from both sides and then divide both sides by 2. And at last we got y equals sine inverse x minus 1 over 2. And let's write this as inverse function. F inverse x equals, this is the inverse function for the given function fx. Now let's graph this inverse function using the rules of transformations. For that, let's rewrite this inverse function as, taken out 1/2, the domain of the original function would be the range of sine inverse function. Now let us see how to get the graph of this transformed function from the basic graph of sine inverse x. Range would be same as the domain of original function, because we know that domain and range of inverse function get exchanged. So this domain of original function would be the range of inverse function. So we already have the range, and looking at this transformed function, we see that there is only horizontal dilation and horizontal right shift. So only the domain values will get changed. How they get changed? First of all, we multiply the domain values, which are -1 to 1 for the sine inverse basic function. They get multiplied by 2. And we get -2 to 2. But then there is a horizontal right shift by 1. So we add 1 to both the endpoints to get the new domain as -1 to 3. So the domain of inverse function would be -1 to 3. And the range would be -π/2 to π/2. Now let's see how to graph this. First of all, let's get the graph of sine inverse x. This is the graph of sine inverse x, and let us see how to get the graph of transformed equation. We have the domain from -1 to 3. That means the left endpoint would be -1 and the right endpoint would be 3. And since the range has the same endpoints, that means -1 at -π/2 and 3 at π/2. So 3 at π/2. These would be the endpoints. Since there was a horizontal dilation by 2 and then horizontal shift by 1, so there would be only the horizontal transformation. And we get the graph of transformed equation like this. This would be the graph of inverse function. So this is how we get the graph of transformed inverse function using the graph of basic inverse function. I hope all this work makes sense to you. Stay tuned for more interesting videos like this. Till then, take care. Bye bye.